Welcome to the Stage 1 Capstone. This is the moment everything you've learned so far clicks into one picture. Over the last 6 lessons, you've built up the vocabulary, the layers, and the mechanics of how data actually moves across a network. Today isn't about new material, it's about consolidation. We're going to take every piece of Stage 1 and lock it into a single unified mental model you can carry into Stage 2. So here's the roadmap for the next few minutes. First, we'll weave all 6 Stage 1 lessons into one coherent mental model. Then we'll trace a packet's full journey end to end, unified, not fragmented. After that, I'll hand you an OSI troubleshooting decision tree you can actually use in the field. And we'll close with self-check questions designed to prove you've truly internalized this material, not just memorized it. Before we synthesize, let's take stock of where you've been. 7 lessons, each one a deliberate piece of the puzzle. From the welcome and the OSI versus TCP/IP framing, through the packet's journey, encapsulation, MTU and MSS realities, cast types, and the devices that move traffic. And now, L07, the capstone. You are here, ready to lock it all into one unified mental model. Here's the unified picture. 11 steps that trace a single packet from a browser click all the way to a server response, with each step tagged to the lesson that taught it. The app builds the request. DNS resolves the name. The local check decides direct or gateway. ARP finds the next hop MAC. Encapsulation wraps the headers. And MTU keeps the size legal, then switches forward at L2. Routers rewrite at L3. The internet hops carry it across. Firewalls and load balancers apply policy, and finally de-encapsulation peels it back open at the receiver. Every lesson, one journey. Now that you can see the whole journey, here's how you turn it into a troubleshooting weapon. Every ticket you ever touch, walk the OSI stack, either top-down from the user complaint or bottom-up from the cable. At layer 1, ask if the link is even alive. Uslink, ethtool. Layer 2, check MAC and ARP. Layer 3, confirm IP, gateway, and routes with IP adder and ping. Layer 4 is the port open and the handshake completing, TSIB dump. And 5 through 7, DNS, TLS, app logs. Lock this decision tree in. It's the difference between guessing and diagnosing. So let's put that decision tree to work on a real ticket. Jane can't reach the company file share over her home VPN, and it worked yesterday. Medium priority landed in your queue. Already, you have 3 useful signals. It's reproducible, something changed recently. And the failure is scoped to VPN plus file share, which narrows your suspects to the tunnel or the file server. Now you apply the OSI tree and work the layers systematically instead of guessing. Walking up the stack, the lower layers all check out. Wi-Fi is up, the VPN tunnel pings, ARP is resolving, and you've got a routable IP with the default route pointing where it should. But the moment you try to reach the file server itself, layer 3 ping fails and a TCP probe to port 445 fails too. Then the telling experiment, a smaller payload sails through while a standard size packet drops. Small works, large doesn't. Lock that pattern in because it's pointing somewhere very specific. That pattern is a classic PM-TUD black hole over the VPN tunnel. The IPsec headers shave the effective MTU down to around 1400, but the sender keeps firing full 1500 byte packets with the don't fragment flag set. A router along the path quietly drops them, and the ICMP fragmentation needed message that should warn the sender is blocked. So small pings succeed, while SMB transfers stall. The fix is MESS clamping on the VPN gateway. One iptables rule tells TCP to negotiate a size that actually fits, 5 minutes with the framework, instead of hours of guessing. So here's your moment of truth, 10 questions, 30 seconds each. If you can answer all of these crisply, Stage 1 is genuinely locked in. Walk through them out loud. Name the 7 layers with a protocol at each. Define the PDU at layers 2, 3, and 4. Explain what changes per hop and what stays end-to-end. If any one of them stalls you, the lesson reference is right there. Jump back, refresh, and return. This isn't a test to pass once. It's a checklist you should be able to run anytime. And once you've run that checklist, this is where you are. Stage 1, complete. You can now reason about any network problem by layer. Read a Wireshark capture without flinching, recognize unicast, multicast, broadcast, and anycast from the address alone. Trace a packet end to end across the internet. Diagnose MTITU and fragmentation when PMTUD breaks and match the right device to its job from layer 1 all the way up to layer 7. These are the mental models every network engineer uses daily, and they're yours now. With the foundations locked in, stage 2 takes you deep into switching, because layer 2 is where most enterprise networks actually live. Across 10 lessons, you'll move from MAC tables and VLANs into 802.1q tagging, inter-VLAN routing, and the full spanning tree family. Classic STP, then RSTP and MSTP. From there, it's link aggregation with Ether channel, port security and DHCP snooping, QoS with voice VLANs, and a capstone that ties it all together. By the end, you'll be designing real enterprise LANs. Before we move on, let's lock in the 5 mental models that will carry you through the next 53 lessons. Networks are layered. Reach for OSI when you need precision. TCP/IP when you need pragmatism. Every packet journey follows the same arc. DNS, ARP, encapsulation, hops de-encapsulation. Remember that layer 2 rewrites at every hop. Layer 3 IPs stay mostly stable, and layer 4 and above run end-to-end. Watch for MTU and PMTUD black holes. They cause some of the subtlest failures you'll ever chase. And whether you troubleshoot top-down or bottom-up, always move layer by layer. And here it all is on one page, your Stage 1 cheat sheet. Keep this close. The models, the packet journey, what changes per hop. MTU, the 4 cast types, which devices live at which layers, your troubleshooting discipline, and the PMTUD over VPN ticket we walked through. If you can glance at this grid and narrate each row from memory, the foundation is locked in. That's the bar. And that brings Stage 1 to a close. Next up, Lesson 8, Layer 2 Revisited, where Stage 2 opens with a closer look at MAC address tables and switching in action. You've built the end-to-end mental model. Now we go deeper into the machinery that makes the local network actually move. I'll see you in the next lesson.